the final, the last piece, the last thing we're going to learn this week is DC motors. And by the way, okay, DC stand for direct current. Okay. Now, what is DC motors? Now, I gave you have a look at those pictures. This is a DC motor. It runs by battery. Okay. As we all know, batteries applies direct current, and the motor operates on direct current are called DC motors. And what does motor do? A motor rotates. Yep. If you connect it with a battery, it rotates. So it's very similar. Well, basically, it is the motors you found in most of the toy cars. And what we're going to do today is I'm going to introduce the basic concept of DC motor. And I'm going to draw a design of DC motor here. However, as you I'm going to draw a design of the motor here, but the design I'm going to draw is not exactly the same design as those ones. Because I'm going to draw the simplest design of a DC motor. Yeah. So just let me draw the design now, and now I'm going to draw the top view first. Okay, now have a look at the top design of DC motor. So what we have is we have a magnetic field from north to south, with magnet. Okay, so the direction of magnetic field will be in this direction. And then I have a battery here, connect with a coil inside, with a shaft. So if I can show, and I'm drawing a dotted line, and this dotted line is the axis, the central axis. Yep. Then let me label every point. Let me label this 4 points A, B, C, D. So when current, so when the motor is in this position, say that's the shaft, that's where it rotates. Now, as you can see, current flow from positive to negative. Okay, so in this case, we have current flow from A to B. It goes through all this flow from A to B, from B to C, and C to D, and come back. Okay. And the important thing is this thing there. Okay. This device with I drew it in red and blue. Okay. This device is called a commutator. It is perhaps the most important device in a DC motor. Okay. I explain. Actually, I will show you what does it do next. Now, after we look at the top view, let me draw the side view first. So I'm going to cut a line in here and produce side views. Okay, if you have a look, okay, now look at the side view. Okay, the current travel from A to B. So in the side view, the current goes into the page at point A and come out of page at point D. And here is the center. In the center, let me draw a line. There's a shaft. Draw a point. Okay. Yep. So now we have a magnetic field and a current. So you can use your right hand rule to find out the direction of force acting. Okay. Pause the video if you need to. Find the direction force first. Now, when I use my right hand rule, I have my thumb into the page and my fingers lined to the right. So my palm facing down. Okay. The direction force is acting downwards at point A. At point D, current come out of page. My thumb come out of page, and my fingers still in the direction to the right, and then my palm face upwards. But the force goes up. So in this case, what we can say is we have a fixed shaft in the middle, and this creates a rotation, basically a torque, anti-clockwise. Okay? Direction of torque is in this direction, anti-clockwise. So that's basically how does a DC motor start to rotate. And yep. Okay. Now, afterwards, after a few seconds, it rotates. Well, the DC motor will be something like this. Point A, point D, the current still goes in at point A and comes out at point D. So again, there will be still upward force. It will be still upward force downwards force at A, upward force at D, and it still the torque still rotates. Okay, until well, if I draw dotted lines in the shaft, okay, at this setup, AD, the shaft AD is going to rotate until point D goes to the left and point A goes to the right. And let's say what's happened when it happens. Okay. Now I'm going to draw it and pay attention, okay, with the commutators. Okay, now that's what we have. So if you have a look at the top view after it rotates, okay, now side CD is going to the left and side AB is going to the right. So have a look with the commutators. Okay, so the blue commutator, the blue side of it will also rotate. That's the beauty of the commutator. It will also rotate. Now, what does the commutator actually do is, the commutator makes sure that the current is always go into the page. If you look at the side view on the left hand side, so yeah, just let me draw it now. But if you have a look, the current doesn't change, the magnet doesn't change, it rotates, and the commutator rotates with the shaft. So if I draw the side view again, okay. Now, sorry, just have a look. Okay. according to the previous diagram, say if the whole thing rotates, okay, I'm going to answer up like something with something like this. Okay? So this is point D and this is point A. Now, now have a look at the top view. So the current is still going through like this. Okay, and come back from positive to negative. So what's happened here is the current in this case is going to flow through from D to C to B to A. Okay, and come back this way. So once point D, once the line CD move to the left, okay, at the point D, the current again is going to be going to the page and come out of page at A. So compare with what's happened before. Okay. Compare with, say, let me just put it in red. Compare with what's happened before. Okay. Now, the line CD is going to be on the left, so the current flows into the page at D and comes out at A. It swaps. So if you do your right-hand rule, okay, you're going to find out that I have a force acting downwards at point D and pulling upwards at point A. Okay. Do your right-hand rule and check whether this is right. Okay. So after a while, it would again this is an anti-clockwise rotation, and after a while, it keep rotating. It's going to answer up like this. I have point D, point A, and the current still goes in at point D, comes out at point A. Then here the forces, so still anti-clockwise rotation. Okay. Then if it rotates, keep rotating, when when the line CD is to the right hand side, the halted situation change to this part again. Okay. And it will keep rotating unless there's no current running through it, through the wire. So this is basically it for DC motors. And yep, the really important role will be the role of the commutator. I will make another video talking about the role of commutator.